Welcome to the DIY Honda Garage channel. DTC P0099 indicates an intermittent interruption in the intake air temperature, or IAT sensor 2, affecting the Honda Civic 2022 and newer models. This error is crucial because it relates to how the engine control module, or PCM, interprets the temperature of the incoming air entering the engine. The IAT sensor plays a significant role in optimizing engine performance by helping the PCM adjust the air-fuel mixture based on air density. These adjustments can influence engine performance, fuel economy, and emissions. Thus, diagnosing issues with the IAT sensor is essential to maintaining optimal vehicle performance. The following guide will walk through a systematic troubleshooting process specifically tailored to this DTC code. DTC P0099 indicates a malfunction of intake air temperature sensor 2, which is crucial for engine management. This sensor measures the temperature of the air entering the engine to aid in calculating fuel injection and ignition timing. It is typically located in the engine bay, often near the manifold, where it can accurately gauge incoming air temperature. When there's an interruption or failure in this sensor or its connections, the PCM, which stands for Powertrain Control Module, detects an abnormality by comparing the sensor voltage to a filtered reference voltage. If there is a significant difference, it stores the DTC P0099 as a way to alert the technician to inspect the sensor and associated wiring for faults. Proper operation of the IAT sensor is vital for maximizing engine efficiency and performance. Several potential causes for DTC P0099 can hinder the function of the intake air temperature sensor 2. Firstly, a faulty IAT sensor itself can lead to incorrect readings, prompting the PCM to flag the issue. Additionally, wiring damage, such as fraying or breakage, can disrupt the electrical signal sent to the PCM, also triggering this DTC. Another consideration is connector corrosion, which can occur over time due to exposure to moisture and contaminants, leading to poor electrical connections. Furthermore, both the MAP sensor and IAT sensor 2 are interconnected, hence malfunctions within one can affect the other. Technicians must methodically investigate these components to identify the root cause reliably. Knowing these possible causes assists in narrowing down the troubleshooting process effectively. When DTC P0099 is triggered, several symptoms may manifest, making it crucial for vehicle operators and technicians to be alert. The first and most obvious symptom is the illumination of the check engine light on the dashboard, which serves as an alert for any engine-related issues. In addition to the warning light, the vehicle may experience poor engine performance, such as rough idling or stalling, which can detract from the overall driving experience. Furthermore, incorrect readings from the IAT sensor can cause higher fuel consumption, reflecting inefficient fuel management due to improper air-fuel mixture adjustments. Therefore, an understanding of these symptoms can guide vehicle operators to seek diagnostics promptly when the DTC is set. Ignoring these warning signs can lead to more significant problems down the line. The first step in troubleshooting DTC P0099 involves bringing the vehicle into the on mode without starting the engine. This allows the vehicle's systems to initialize and prepares the PCM to be checked. Technicians should verify the connections to the PCM, or Powertrain Control Module, ensuring they are secure and free from damage or corrosion. Alongside this, visual inspection of the MAP sensor and the IAT sensor's connector is crucial, given that worn or corroded connectors can lead to intermittent failures in sensor operation. Making sure they are intact is essential before proceeding further. This step sets the foundation for diagnosing potential wiring or sensor issues. thus ensuring an efficient troubleshooting process. After confirming connections, the next step is to disconnect the map sensor and IAT sensor to isolate them for inspection. It is vital to check the circuits labeled TA, which represents the signal circuit, and SG5, the ground circuit, to ensure they are functioning correctly. The inspection should focus on identifying any possible open circuits, which can stop the sensors from sending information to the PCM. The testing should ensure less than 1 ohm of resistance in the wiring to confirm proper connectivity. Also, if there's a fault or interruption, it's critical to use a multimeter to measure the circuits. This methodical approach aids in verifying whether the issue lies in the wiring or the sensor itself, streamlining the diagnostic process. The third step in diagnosing DTC P0099 requires checking the signal circuit, TA, for any potential shorts to ground. You should measure the resistance. A reading of more than 1 megaohm, MO, indicates that the circuit is functioning properly without a short. This testing is crucial, as a short to ground could lead to a false reading, causing the PCM to register an error code. Verification includes ensuring that the sensor can operate within specified normal conditions, which is vital for confirming the health of the IAT sensor. If abnormal results are obtained, it points towards issues with the wiring or the sensor to be addressed further. This step is essential for narrowing down the cause of the DTC effectively. After completing the necessary repairs based on findings from the previous steps, the final verification process for DTC P0099 entails clearing the DTC from the system. This is accomplished using a diagnostic scanner connected to the vehicle's PCM. Once cleared, a test drive is essential to ensure that the vehicle operates correctly and that there are no signs of the DTC reappearing. Monitoring the vehicle during this test drive enables technicians to validate that the implemented repairs were effective. If the DTC does not reoccur, it confirms that the issue was successfully diagnosed and resolved. Hence, this verification process is critical to ensure the reliability of the repairs conducted in the troubleshooting stages. Preventive maintenance regarding DTC P0099 involves rigorous and regular inspections of the intake air temperature sensor and associated wiring. Technicians should routinely check these sensors to catch any potential issues before they lead to failure. Additionally, ensuring that connectors remain clean and free from corrosion can greatly extend their functional life. This can be accomplished by using connector cleaners and dielectric grease to protect against moisture and contamination. Periodic inspections of the wiring should also be performed to look for signs of wear or damage, which can prevent the smooth operation of the sensors. Such preventive measures help maintain optimal engine performance and reduce the likelihood of DTC codes as triggered. In conclusion, understanding and effectively addressing DTC P0099 requires a systematic approach to troubleshooting the intake air temperature sensor and its related circuits. Being aware of the potential symptoms and causes plays a vital role in identifying the underlying issues promptly. Following each troubleshooting step allows for thorough diagnostics, ensuring that all components are checked adequately. Once repairs are made, verification steps confirm that the vehicle operates correctly without recurring DTC codes. Additionally, implementing preventive maintenance strategies can minimize future problems and enhance vehicle reliability. Keeping abreast of these practices can solidify optimal performance for the Honda Civic models 2022 and newer. Please like and subscribe to the channel. See you next time.